All right, so we are going to be learning about area of a circle. So we're going to start off by showing you the formula, but in the video, not only are we going to learn about the formula, I want to explain why the formula is what it is. When I learned about area of a circle, I don't quite remember being given a justification as to why we're using that. I just remember having to learn the formula. And so the formula for the area of a circle is the area is going to be equal to pi times r squared. So I'm going to explain a few things as to why it is going to be what it is. So first, I'm going to start off with the circle that we have here. And so I've cut this circle up into 8 pieces. I've numbered all of the circles on here. But what happens is when we cut the circle up into pieces, we notice that we have a triangle. And what we can do with each of those pieces is we can take it and rearrange it similar to what we have here. And when we rearrange it, we start to see a shape that looks like a parallelogram. And if we remember the formula for the area of a parallelogram, we remember that the area of a parallelogram is, and I'll put this up here, parallelogram is equal to, the area is equal to base times height. Okay, so we take the base, this would be your base here, and you would multiply it by the height. Okay, so it's going to be the similar thing when we start talking about the area of a circle. We're going to use the same type of concept, but I want to show you what happens if I take my 8 pieces and now I cut it up into 16 pieces. So now we have a circle, it's been cut up into 16 pieces. The pieces are smaller, and so as we rearrange those, this is what we end up with. So now we're starting to notice that it does look more and more like a parallelogram. And our first example that I had was here. So notice that it's starting to look more like a parallelogram, which confirms, again, that formula that we're going to be using for the parallelogram, which is area is equal to base times height. So let's say that I take my circle and I cut it up into even smaller pieces. Okay. And so now this is what it looks like. So the pieces are smaller, and now that they're smaller, we're going to take it and rearrange it. And look at it. It's looking, I mean, really close to a parallelogram. In fact, it looks like it's getting closer to a rectangle. And again, the formula for a rectangle is length times width or base times height. So it's the same thing. And so one more example where I took it and I cut it up into even smaller pieces. And it was so small that I couldn't even put the numbers on there. Um, but you will see that we have our odd numbers and our even numbers on here. And then here is what we end up with. Okay. So now it really does look like a rectangle. So what I'm trying to show you is that the more that we cut our circle up into pieces, the more that it looks like a rectangle. Okay. If it looks like a rectangle, we still use the formula for the area of a parallelogram. And so let's talk about that real quick. So remember that when we talk about a circle, remember there's a few pieces on there. When we look at a circle, we notice that there's a center, okay? And the distance from the center to the edge of the circle is called our radius, right? So we have a radius, and that same radius is what's used to go all the way around the circle, okay? And so remember that when we take the circle, I'm sorry, the center, and we go to the other side, we have another radius here, right? So we have one radius, we have a second radius here. Remember that two of those radii become your diameter, okay? So that's something I want you to remember. Now, let's think about our formula for the area of a parallelogram. We say that the area of a parallelogram is going to be base times height. Base times height, right? So we're going to do the same thing with our circle. Now, this is going to be our ending formula for the area of a circle, but I'm just going to give you the reason as to how it becomes what it is, okay? So in this example, we will have our area is equal to the base times the height, okay? And our base is going to be this here, okay? And notice that this base is basically half of the circumference, right? So our circumference is the total distance around the circle, but it's halfway across if I was to take this and place it on top if it was smaller. Really what we have is 1, 2, 3, 4 pieces, 1, 2, 3, 4 pieces. And so that's half of your circle. So let's go and say that the area is now, instead of saying the base, we're going to say that that is equal to 1/2 of the circumference. Okay. And then we're going to multiply that by our height. Well, our height is going to be from the base to the highest point. And if we look at our circle, remember we're talking about our circumference. We're using half of the circumference. We go from the base to the height. That's basically your radius, right? So what you're saying then is that 1/2 the circumference is your base, and the height is going to be known as your radius. Okay, so that's how we've gone. Let me use a different color because this one is not showing. We'll say area is equal to base times height. And then just rewriting that, that is the same thing as 1/2 of your circumference times the radius. Okay. So now we just need to go a step further. So what about this 1/2 of the circumference? Well, what is that? Well, we know that the circumference is equal to, we know the circumference is equal to twice the radius times pi. So remember that the circumference, again, is going to be twice the radius times pi if we're talking about the radius, okay? And so what do we have? So then we have area is equal to 1/2. Instead of the c, we're going to replace it with what we know the circumference to be. The formula for circumference is twice the radius times pi. So we're going to say 1/2 2 times r times pi. Okay, so all of that, and we're going to multiply that by r. Well, now what we're doing is just simplifying. We're just simplifying this so that we can get back to our original formula. Okay, so what we have is going to be then area is equal to, we have 1/2 times 2. Well, half of 2, in other words, 1/2 times 2, that's the same thing as 2 over 1. 2 divided by 2 gives me 1, and 1 divided by 1 gives me 1, right? So this gives us 1, okay, times r times pi, and then we're going to multiply that by r, okay? Well, remember that we don't need to have a 1 inside of here. We don't need to have a 1 to represent the r or the pi, because we know that that's what it is. We see one of those there, so we're just going to simplify it a step further by removing the 1 and just leaving it as r times pi. And now we're going to multiply that by r. Okay. So now what we can do is remember where we've learned about like terms. I see that we have a r and we have a r. So that's the same thing as saying r times r. Okay. And we've learned about exponents. So when we see that a number or a variable is being multiplied by the same number or variable, then we know that we're just saying this is r to the second power. Okay. So then what we end up with is going to be area is equal to r squared times pi, which is the same thing that we have up here. Now, up here we have pi r squared. A lot of times you'll hear people say that area of a circle is pi's r squared. That's a way for them to remember. It doesn't matter which way you have it written down, as long as you remember that you are going to have the radius squared times pi. That is going to give you the area of the circle. So this is how we got this formula there. So I hope that helps you out a little bit. In our next examples, we'll be going into using this formula so that we can solve for the area of different circles.